All right, well, this is the topic quiz you should have taken home last night and gotten done, and we're going to correct it here today. If it was difficult, good. It's supposed to be difficult. This is an awesome, challenging assessment with some really high-level algebra things on it. So let's go ahead and take a look at problem 1. So first of all, it says, apply the distributive property to write an expression that is equivalent to expression g. So I'm paying attention to expression g first, not anything else. So distributive property means I'm going to take 2 times all of the terms on the inside of the parentheses. So that means I'm doing, this is equal to 2 times 3x plus 2 times 10. So all I have to do is evaluate these terms and I can generate that expression. Well, 2 times 3x is 6x. And then 2 times 10 is 20. And of course, what am I doing with those terms? They are being added together. So I get this new expression of 6x plus 20, and that's equal to what we started with because we used the distributive property. Okay, so that's part A. Part A is done. So make your corrections and let's move on. Part B, it says to explain whether or not g and h are equivalent using any value of x. So remember that I can pick any value for x, and I'm working with these two expressions. I'm working with 2 times 3x plus 10, but I'm also working with 6x plus 12. So think, what values can I pick for x? I can pick any values for x. Any values at all. Don't copy this down yet. So let's say x is, 2 is a pretty simple number. If x is 2, let's plug this in and show what this is going to look like. So if I have 2 times 3x plus 10, I said x is 2. Well, let's do that. 3 not times x, 3 times 2, because I said x was 2. Plus 10, in parentheses, all of that times 2. In the other one, I'm going to end up with 6 times x. What's x? We said x was 2. So 6 times 2 plus 12. So we've got all these expressions to work with. So let's actually see what happens. Again, this is expression g over here. This is expression at h. Let's see what happens. Okay, so let's do this order of operations style. I have parentheses, so I got to do those first. Then it's multiplication or addition. Most powerful is multiplication. So I end up with 2 times 6 plus 10. And then I do parentheses again. 2 times 6 plus 10 is 16. 2 times 16 is 32. So expression g evaluates to 32. On this one, 6 times 2 is 12. 12 plus 12 is 24. So when x was 2, do they evaluate to the same number? Are 32 and 24 the same number? No, they are not. So would we say these are equivalent or not equivalent? We should say these are not equivalent because they don't evaluate to the same number. So that means g and h aren't the same thing. That means these two, if I wrote this down, if I told you this right here, I would be lying. This is not true. Not true, so they are not equivalent. So let's think about how we can write this. So here's some blanks with your writer CFS. I encourage you to pause here and try to fill in the blanks on this explanation, because showing our work isn't enough. We actually have to explain using our writer CFS. So pause, see if you can fill in the blanks. All right, so hopefully you're back. When x is, we said 2, it can be seen what each expression, what was the fancy word I used to find the answer? What each expression evaluates to. Evaluates to. Expression g is 32. Expression h is 24. Therefore, the expressions are not equivalent. And again, it's because they do not evaluate to the same number. If you need to pause and go back and try to understand that correction, I encourage you to, not just copying, you're also thinking about what we're doing. Let's go ahead and flip it over and look at the other problem. So we're given two situations here. We're given situation 1, which says Charlie has 3 times as many baseball cards as Ramon. If Ramon has X number of baseball cards, how many does Charlie have? So let's talk about situation 1 first. So Charlie has 3 times as many, right? So if I have Charlie and I have Ramon, that means I know Charlie has 3 times as many. This means if Ramon has 2, Charlie must have 6. If Ramon has 10, Charlie must have 30. But we only know Ramon has X. Ramon has X, so Charlie must have 3 times X. So situation 1 is represented by 3 times X. Emily, let's take a look at situation 2 then. 3 times X. Emily has 3 more bracelets than Amy. If Amy has X number of bracelets, how many bracelets does Emily have? So now it's 3 more, not 3 times as many. 3 times as many made us think times 3. 3 more than should make us think plus 3. So if I have Emily and I have Amy, right? Emily has 3 more than Amy. So it means if Amy has 0, Emily must have 3. If Amy has 10, Emily must have 13. So then it says if Amy has X number of bracelets, oh, sorry about that. If Amy has X, so let's go back through that. If Amy has 0, Emily must have 3 because she has 3 more. If Amy has 10, Emily must have 13, 3 more. If she has X, she has whatever X plus 3 is. So our expression for situation 2 is X plus 3. But it wasn't enough just to write an expression for each situation. We have to actually explain why these are the same expression or why they are not. So let's think of some facts I can state. So I need to state at least 2 facts about what I've shown. So situation 1 uses 3x as its expression. Because let's think about what led us to think that. What words helped us think that? 3 times as many, because 3 times as many means multiplication. So now this is about situation 1. Try to pause the video and see if you can write a fact about situation 2. You can get started like this. Situation 2 uses x plus 3 as its expression because. So I'd encourage you to pause and see if you can finish that fact up. Okay, hopefully you're back. Situation 2 uses x plus 3 as the expression because what words helped us here? Because 3 more means addition. So now let's see if we can write our assertion. Let's see if we can write our assertion. The question said, are they represented by the same expression? So we should say, therefore, they are not represented by the same expression. So that should help us. We've got our models shown, we've got an assertion, we've got multiple facts. This is a pretty good looking answer now. Hopefully you've got that correction made on yours.